Hey guys, welcome back. Just a reminder that next Wednesday, December 16th, is the deadline for all retakes and makeup work. Okay, so if you're missing something for me, or you want to retry something on Google Classroom, or you want to retake a quiz or test, all of that needs to be done by the end of next Wednesday. Okay, that is the deadline. So make sure you get that work in to me. Otherwise, it's going to go in the grade book as a one, right? It should be in the grade book as a one right now, and it will not change. Okay, so if you want to get that work done, any makeup or retakes, get it in by next Wednesday, December 16th. I'm on page 300 right now. This is example one. So if you'd like to follow along in your ebook, you can do that. But today we're going to add and subtract mixed numbers. And I have two methods to show you today. There's two ways to do this. And one of the ways you're probably pretty familiar with, but I have a second way that I think is very safe. I think you're less likely to make a mistake doing it the second way. So that's something that you can try. Now, I would also suggest whatever you feel most comfortable with is what you go with. Okay, so either method will work, and whichever one you like, go ahead and do that to solve these problems. So the first thing we want to do when we're adding and subtracting, just like we do with regular fractions when we're dealing with mixed numbers, is see if we have common denominators. And in this problem we do, right? Each of them is 9. So we can just add, right? We can just add what the top tells us to, right? What is 4 plus 2? Well, 4 plus 2 is obviously 6, right? It's obviously 6. And our denominator is 9, so that's going to stay as 9. So we have 6 over 9. And we then can add the big numbers, the bases, right? We have a 7 plus 10. 7 plus 10 is 17, okay? So this answer for problem 1 can be written as 17 and 6/9. All right, so if you wrote your answer like this, I wouldn't count it wrong, but hopefully you notice that this 6/9 can be reduced, right? There's a 3, right? The greatest common factor between 6 and 9 is 3, and we can divide both of those by 3. So I'm going to just bring my 17 down here. 6 divided by 3 is 2, and 9 divided by 3 is 3. So this problem is 17 and 2/3. Once again, if you wrote it as 17 and 6/9, I wouldn't count that wrong since they are equivalent. It can just be reduced to 17 and 2/3. Right, so the second way to do this, right, and I remember, or hopefully you remember me telling you that I have a way that I think is potentially easier, and we'll see if you agree. Well, I guess I didn't say it's easier. What I said was it's safer. All right. So if you're worried about making mistakes, I think this way is easier. I would turn them into mixed numbers. Sorry, I would turn them from mixed numbers into improper fractions, right? And I would do that because then we don't have to worry about these big numbers. We can just add them as improper fractions. So to do that, remember we times, right? We say 9 times 7, right? 9 times 7, which is 63. And we say 63, and then we add the top number. So 63 plus 4 is 67. All right, so this would be 67 over 9. 7 and 4/9 is 67 over 9. And then I would say 9 times 10, right? 9 times 10 is 90, and 90 plus 2, right? Because we add the top. 90 plus 2 is 92. Okay, so I have 92 over 9. All right, and I know you're probably like, oh man, these numbers are so big, right? Well, you do have a calculator, right? I would just add those in your calculator, 67 plus 92, and that should be 159, I believe, 159. So you can leave your answer, right, as this improper fraction. Okay, you can leave it as 159. Now, The other option is this can be reduced, right? Because both of these numbers can be divided by 3, okay? So 3 goes into 15 5 times, and 3 goes into 9 3 times. So 159 divided by divided by 3 is 53, and 9 divided by 3 is 3. So you could leave your answer as 53 over 3. That is an acceptable answer for this problem. And if you wanted to turn 53 over 3 into a mixed number, right, which should be 17 2/3, well, how many times does 3 go into 53? Well, the answer is 17, right? Because 17 times 3 is 51. And the remainder of 51 and 53 is 2, right? 2/3. Okay, so there's 2 ways to do this, right? You can add them like this, which is probably the method you're familiar with. However, I think that making the mixed numbers can be beneficial as well, especially when we're dealing with negative signs and subtraction. Okay, so let's look at another problem here. That was example 1 on page 300. Let's go to example 2 on 300. And again, I'm going to show you both ways to do this. Okay, so number 2 says 8 5/6 minus 2 1/3. So let's look at the denominators and let's see if they are common. Well, the answer is no, right? This one's obviously a 6 and this one's a 3. Those are different. So what we need to do is we need to turn this 2 1/3 into something out of 6. Okay, so if we times the 3 by 2, that would give us 6. And if we times the bottom by 2, we need to times the top by 2. Okay, so I have, and I'm just going to rewrite the whole thing over here. I have 8 5/6, right? Minus sign 2, and 1 times 2 is 2, and 3 times 2 is 6. Okay, so 2 1/3 is the same as 2 2 6. All right, so let's see if we have common denominators. The answer is yes. So we can say 5 minus, get a little wonky up there. 5 minus 2 is 3. So we have 3 over 6. What's 8 minus 2? That answer is 6. So we have 6 3/6 is our answer. Now, hopefully you notice that 3/6 can be reduced into 1/2, right? If we divide both numbers by 3, 3 divided by 3 is 1, and 6 divided by 3 is 2. So this is 6 1/2, right? This is 6 1/2. Now, another benefit, I think, right? Another benefit, I think, of turning these into, this is method 2 now, turning these into from mixed numbers into improper fractions is we can kind of skip a step and put it at the end, which is what I'll show you now. So if we were turning these into improper fractions, 6 times 8 is 48. We add the top number, 48 plus 5 is 53. So this is 53 over 6 minus 3 times 2 is 6. 6 plus 1 is 7. So this is 7 over 3, right? This is 7 over 3. And we still, remember, we need to make it out of 6, right? We need to make it out of 6. So I need to times the 3 by 2 like we did earlier, and times 7 by 2. 7 by 2 is 14. And 3 times 2 is 6. So we get 53 over 6 minus 14 over 6, which should leave us with 39 over 6. Now this fraction, right? This fraction can be reduced. Both of these are divisible by 3. So 39 divided by 3 is 13. And 6 divided by 3 is 2. So that we can leave our answer as this improper fraction, 13 over 2. And if for some reason you wanted to change it into the mixed number, which you could, it should be 6.5. So how many times does 2 go into 13? The answer is 6, right? And because 2 times 6 is 12, and the remainder between 12 and 13 is 1. So you can see it's also 6.5. Okay, so let's try another one. And I think this problem is a good example of why I like using the improper fraction method. Okay, let's take a look at problem 3 here. All right, problem 3. So I have 2 1/3 minus 1 2/3. Okay, 1 2/3. So this is going to get a little funky, right? We got the common denominator is still 3, right? The common denominator is 3. So we can just say the top, 1 minus 2. Now that's kind of a problem because 1 minus 2 is -1, right? It's -1. So this is -1/3. And I think that this is where a lot of people kind of get lost, right? We subtracted them. 1 minus 2 is -1. So 1/3 minus 2/3 is a -1/3. And then we would have to subtract the base, right? What's 2 minus 1? Well, the answer is 1. Okay, so here we have 1 and -1/3, which, can be confusing, right? What is 1 and -1/3? It's not, right? We can't just put the negative out front and make it -1 1/3. That's not legal. Okay, what this really is telling us is that it's 1 minus 1/3, right? And it is a little confusing. So what we need to do is now change this 1 into a fraction, right? Which is 1/1. And we can see that they don't have common denominators, right? This one has a 1 and this has a 3. So we need to times this side by 3 on the top and bottom. So this is 3/3 minus 1/3. And 3/3 minus 1/3 is 3 minus 1 is 2. So this is our answer at 2/3, right? It's 2/3. I don't know if you can see it down there. All right, but I think it gets a little funny when the fraction in the front is smaller than the fraction in the back, right? 1/3 is smaller than 2/3, and we're subtracting. So I'll show you the other method, and I'll let you decide for yourself which one's easier and which one is, as I said, which one is safer. Okay, I don't know if you can see my other hand there. Safer, okay? So let's go ahead and go back. We know our answer is supposed to be 2/3. Let me put that back up there. All right, so if I'm making these improper fractions first, remember we times the bottom with the big number. So 3 times 2 is 6. We add the top number. So that is 3 times 2 is 6 plus 1 is 7. So this is 7/3 minus 3 times 1 is 3. And 3 plus 2 is 5. And you can see this is going to be a lot easier to get this answer of 2/3, right? So I know the first couple of problems, it looked like using this method was harder maybe, but I think it's safer because when you have a fraction that's not as big as the second fraction and you're subtracting, or if we were like adding a negative fraction, I think it's just easier to keep track of your numbers here. Obviously, 7 minus 5 is 2, and the denominator would stay a 3. So this is 2/3. Again, I will let you decide which method you want to use and which one you think is safest or easiest. Let's go over a page to, this is 302 now, and this is a word problem. So I'm going to go ahead and write it down on the board. And if you want to, skip the video ahead a couple of seconds here, that's okay with me. Otherwise, just kind of hang tight. Maybe send a couple of TikToks out or something, check up on your Snapchat streaks, what your pals and gals are up to these days. You can also think about how lame of a math teacher you have who says pals and gals. All right, so a lot of words up here, okay? A lot of words up here, and I'll scoot kind of out of the way, all right? So it says an urban planner, all right? That's like a city design person. So an urban planner is designing a skateboard park. The length of this park is 120 and a half feet, okay? So I'm going to go ahead and circle that because I think it's important information that we will use later. Right, I have 120 and a half feet. Okay, and the length of the, and I just put a P, but the length of the parking lot is 40 1/3 feet. All right, so the next part's important because it's going to tell us what we're doing with the 120 and a half feet and the 40 1/3 foot. It says, excuse me, it says how long are they combined? So I'll give you a second to think about combined. Does that word mean add or subtract? Well, it means add. So hopefully you figured out that we need to say 120 and a half plus 40 1/3, right? We need to add those two numbers. I got 120 and a half plus 40 1/3. So let's go ahead and look. We're going to do this both methods, right? Just like we have been. Do these have common denominators? Well, the answer is no, right? We have a 2 and a 3. So the first thing I'm going to do on this one, right, is I'm going to times it by 2, right? Because I need to make the 3 and the 6, or the 3 and the 2 turn into 6. So 2 times 3 and 1 times 2. So this gives me 40, right? 40, and 2 times 1 is 2. And 2 times 3 is 6. And now this side I will times by 3 and 3. So I have 120. 3 times 1 is 3. And 3 times 2 is 6. And now we have common denominators. So let's go ahead and add our tops. What's 3 plus 2? 3 plus 2 is obviously 5, right? 5. Our denominator stays the same, which is 6. And now we can add our base, which is 120 plus 40. 120 plus 40 is 180. Okay, and we had feet in here because it's a word problem. So how long are they combined? Well, the answer is they're 180 and 5/6 feet combined length. That's how long these two things are together. Now we can also go and do this the other way, right? We can do this the other way. So I'm going to erase the words here since we have, we already wrote the problem down in this purple ink right here. So what I'm going to do is I'm going to erase everything else. We have a lot of space here. And I'm going to turn these into, improper fractions, okay? starting at this step, right? So, all right, I have 120 and a half and 40 and 1/3. So I'll start with the 40 and 1/3. We times, right? 3 times 40 is 120. 120 plus 1 is 121. So it's over 3. 40 and 1/3 is 121 over 3. And now 2 times 120, right? 2 times 120. I don't know if you can see my time sign there. Doesn't look like it. Put a little times in there. Okay. 2 times the 120 should be 240. We add that to the 240 is 241 over 2. Okay. And that's what these two are as improper fractions, right? And so you can see, we still need to make these the same, right? We can still need to make these the same. So we need to times this by 2 and 2, and we need to times this by 3 and 3. And now you might be wondering, hey, this looks way harder than it was because those numbers are huge. And the answer is, yeah, it's going to be a little harder because our numbers are big, but we do have a calculator. Secondly, maybe you are going for like a mix and match type strategy, right? When the numbers are big, you can use the first method. And when the numbers are small and maybe negative, you can use the improper fraction method. But let's continue to solve this problem. I'm going to type in 241 times 3. That should be 723, right? So 241 times 3 is 723. And we know that 2 times 3 is 6 plus, right? Plus 121 times 2 should be 242. And this should go over, let's see, 3 times 2 is 6 as well. So I got 723. 723 plus 242 is going to give me 965 over 6. Okay, 965 over 6. And 965 can't be divided by 3. It can't be divided by 2. So our answer can stay as this improper fraction, right? It can stay as that improper fraction. There's no need to turn this into a mixed number. All right. If you wanted to, you could, but you can leave it like that, and I would accept it. All right, we're going to try one more word problem. I know you're probably dying to get done with this lesson, but we're going to try one more word problem together. So if you want to go ahead and skip ahead while I write it up on the board, that's fine. This is number 4. It's a little bit shorter. That was example 4. This is actually number 4 on page 302. All right. Let's see. All right. Okay, so this one says a car can hold 11 9/10 gallons of gas in its tank. It currently has 8 3/4 gallons of gas. Okay, so I've got the whole tank can hold 8 9/10, and currently has 8 3/4 gallons of gas in the tank. So how much more is needed to fill the tank? So I want you to think for a second what we need to do with these two numbers in order to find how much more can fit in the tank. Well, we would want to subtract, right? If this is the max amount that we can hold, and if we subtract the amount that's already in there, right, which is 8 3/4, then that will tell us how much more is needed to fill the tank. So first things first, we need to make these two into common denominators. Now, you could just say 4 times 10 and make it 40, but there's a smaller number, a least common multiple of 20. So if we say 4 times 5, we get 20. If we say 2 times 10, we get 20, which is the least common multiple. So 5 times 4 is 20, and 5 times 3 is 15. So this is 8 and 15 20s, and this is 11 and 18. Oops, that's not a very good 8. 18 20s. All right, so this one looks like the first method. This one's pretty easy, and I'm just going to show you the first method here. Okay, you could do it the other way if you wanted to, but I'm going to just do the first method here because it's probably a little simpler. So we have common denominators now. What is 18 minus 15? 18 minus 15 is 3. So it's 3/20. And what's 11 minus the 8? 3. So it looks like there is 3 and 3/20 gallons, right, of gas that could still fit in the tank. Again, you could turn these into your mixed numbers. Turn them from mixed numbers into your improper fractions and do it that way as well. But hopefully we have had enough practice with that to do that moving forward. So, guys, I have a couple of problems that I want you to try for next week, right? Next Monday or Tuesday, depending on when you have me. Let's see here. So I want to go to, all right, a couple of problems here. I want to go to, this is page 303, right? And the problems, let's see, where was that? Oh, yes. Okay. The problems here are numbers 2, 3, 6. Watch out for 6, by the way. I would suggest on number 6, I would suggest maybe doing it the second method on number 6. So watch out for 6 and try 8 for me as well. So 8 is another one that I would watch out for, and maybe try method 2 on number 8. And then the last problem I want you to do is number 10. Okay, so we're doing 2, 3, 6, 8, and 10 on page 303. That will be due on either Monday or Tuesday, depending on when you have me. Reminder, guys, that next Wednesday, 12/16, is the last day for all makeup and retakes. Okay, so make sure that if you want to retake a test or quiz, that you can do, you have enough time to do that by Wednesday. And anything on Google Classroom that you're missing, you can do as long as it's in before that deadline. Good luck. If you need help, see me during office hours, send me an email. I'll jump on Google Meet and we will work these problems together. Okay?